Okay guys, this is the second half of the probability experiment on page 468 in your book, page 203 from your test and worksheet book. I went ahead and I did my tallies and I had my daughter. So basically I rolled 36 times, like I showed you some, and put a tally mark for every time it landed on a 4. I put a tally mark, a 5, a tally mark, which see my 5s, there just weren't many. And then I had her do the same thing, okay? So both of these happened 36 times. So if I add them together, I have 5 here, and I have 7 there. And so 5 plus 7, I'm adding them together and getting 12. Then here, she had 11, and I have 7, so that's 18. Here, she had 8. And I had 6, so there's 14. Then here she had 4, and I had 5, so that's 9. Here we had 1, 2, 3, 4 total, not very many. And then we had 5, 10, and 4 more makes 14. So I just added those up to determine our total frequency. Your numbers will look different from mine, and that's okay. I just did my numbers so that I could show you what to do. Now, we have a question to answer in the book about this. Now, my numbers are all over the place, but we'll see what our question says. On number 19, what conclusions can you draw from the results of experiment 1? Well, on the results of experiment 1, we should be able to say that they're roughly equal. Ours, for some reason, are not. I don't know if my dice are funky or what, but the numbers should be a lot closer together. There shouldn't be, for some reason, this number 5, rolling a 5 was really hard. So it's really, really low, but your numbers will probably be a lot closer on these. What it's trying to show you from this is that in general, the chance of rolling each a 1, a 2, a 3, a 4, a 5, a 6 should be about the same. So that's our conclusion really, is that the number of outcomes, I spelled that wrong. Let me start that over. Outcomes should be close or close to equal. Mine are not, but yours probably will do much better. I don't know why mine turned out so strange. Okay, so now we move on to the second piece here. This is experiment 2, and to do it wants you to look at and roll, this time you're going to be rolling 2 cubes to make your tally. You'll be doing your student tally, I'll do the teacher tally, and basically you're rolling them. You notice when you roll them together, your outcomes you can get, the lowest outcome you can get is a 2, and that's if you rolled a 1 and a 1 on your dice, you would get a 2. But then if you roll, the highest you can get is if you rolled a 6 and a 6, which is a 12. So you're going to be adding them together. So I'll do a couple examples. I ended up with a 3 and a 1, which is a 4. So I'm going to go to my page on my teacher tally, and I'm going to put, where's that? A 4. Oh, the predictions. I forgot to tell you the predictions. So the predictions, you can put these numbers in, 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. The reason is it's all about the combination of dice, okay, to make that number. So the only way, there's one way I can make a 2 when I add my dice together. There's one way. So that's very hard to roll that. So that's why I predict that to be very low. But when I get toward the middle of my numbers, 5, 6, 7, there's multiple ways. For example, for a 6, I could roll a 1 and a 5. I could roll a 4 and a 2. I could roll a 3 and a 3, and those would all equal 6. So I've got more possibilities of ways to equal 6, so therefore I think that's going to be more frequent. Then when you get to 7, you have even more possibilities. You could roll a 5 and a 2. You could roll a 6 and a 1. You could roll a 3 and a 4. So you have a lot of possibilities to make up 7, so that's why that's the highest on my prediction. So you can copy these predictions down. Notice they equal 36 because that's the number of times we're rolling. So I did one roll, I'm gonna do a couple more, and then I'll turn the video off and come back with part 3, which will be the last two questions of our investigation.